All right, so bear with me as we do these challenge questions. These challenge questions are a challenge, so just be aware. So there is going to be a lot of crossing out, kind of moving things around. I don't have a tintenkela on me, so I am still just going to continue to use my fola and cross out as we go. It'll also have us an opportunity to kind of see where we were. So this one, we only have 3 atoms. We got carbon, we got hydrogen, and we got oxygen. I'm going to go ahead and count. We got 3, 1, we got 6, and then we have 2, and so then here we've got 2, and then this is also where it's going to be tricky. We've got O2, we got 2 oxygen here, but we also have another one there, so that's going to have to be 3. So please notice we got that odd number and even number. That's not going to be very fun. Anytime you see that, that's always going to be kind of a pain. So we can choose to go anywhere, really, to kind of get us started. So I'm going to go ahead and do kind of a natural way to figure out where we're going to go, is I'm going to put a 3 in front of this CO2. So that's going to make our carbons balanced. And what's that going to do to our oxygen? So 3 times 2 is 6, plus 1, that's going to give us 7. Did this get us anywhere? No, that did not get us anywhere. Maybe this is going to help. So let's check this out. Let's try to put, here we have a 6, and here we have a 2. 6, I need to figure out what number would I put in front of here to make this 6 hydrogens. So if I put a 3, right here, we got 3 times 2. Oh, now we got that. So maybe we can get to an even number. 3 times 2 is 6 oxygens. 3 plus 3. 3 times 1. 3 times 1 is 3. So we got 6 plus 3. We end up with 9. Check it out. We've got another odd number and even number. These are balanced. These are balanced, but then these pesky little oxygens, that is not balanced. That is going to be the tricky part here. Here is my tip anytime you end up with an equation like this. Anytime you have a equation where you have, okay, an uneven or an odd number and an even number, double everything. So right now we have 1 there, and if I was to actually, so we're going to double everything except for this O2. So I'm going to double everything. So that's going to be our easiest, and then we can go through. So if I double everything except for that O2, I'm going to double this. I'm going to double this. So that now we're going to go through count again, and then we will try to figure out what's going on for that O2. So how many carbons? 2 times 3 is 6. Then that means on this side we've got 6. 2 times 6 is 12. Then 6 times 2 is 12. So now we still only have 2 on this side, but check this out. 6 times 2 is 12. Then 6 times 1 is 6. 12 plus 6 is 18. Now we can break this down. Now we can see what number can we now put in front of here. We have 2 even numbers. Sweet. Now we can actually figure out what number we can put in front of this O2. So what times 2 is equal to 18? 9. You got it. So then 9 times 2 is 18. We have 6 and 6, 12 and 12, 18 and 18. Lovely. That is our first question. That's why these are challenging. So if I was to ask you about the coefficients on this question, it would be 2, 9, 6, 6. That is your correct answer on that one. Whew. Yeah. See, these ones are tricky. I encourage you, find a website if you want, or I can send you a website and recommend some challenge problems. These can be tricky, but also they can kind of be fun. So this one here, looks very similar, but slightly larger molecule. Here we've got our carbons, we've got our hydrogens, and we got our oxygens. I've got 8. Excuse me. I've got 8. I've got 1. I've got 16. We've got 2. We've got 2, and then we've got that silly again, that pesky, unbalanced here. So diving in. We got an 8, we got a 1, we got to put an 8 in front of here. So 8 times 2 is going to be 16 plus here. But check it, before we count here what's going on with the oxygens, let's back up here. Let's try to balance these these hydrogens, and that will come a little bit more clear for you. You'll see it in a second. So 16, we got 16 on this side and 2 on that side. So what times 2 is going to give us 16? We're going to end up with 8. So then we end up with 16. Now let's recount our oxygen. So we got 8 times 2 is 16. 8 times 1 is 8. So 16 plus 8 is 24. Check this out. So what, on this side now, what times 24 is going to be, or excuse me, what times 2 is equal to 24? What number do we need to put in front of here? If you're thinking 12, you are correct. So now we have 24 on this side and that side. Again, asking for coefficients, we'd have 1, 12, 8, and 8. A little bit easier challenge question than the previous one, but that one can kind of also be a pain. Those combustion ones are kind of a pain sometimes. So here is our challenge question number 3. Challenge question number 3 is certainly a challenge. When we start looking at it, it looks like it's kind of a mess because there's so many different atoms in this one. So we've got our carbons, we've got our hydrogen, oxygen, phosphorus, chlorine. Whew, this one's tricky. So let's just go ahead and start counting though. We got 2, we got 2, we got hydrogens, we got 4. We have to make sure we look on both sides. Here we got 3, and here we have 3. So 3 plus 3 is 6. We got oxygens, we got 2. We got 1 oxygen here. We got 3 oxygen. 1 plus 3 is 4. Phosphorus, we've got 1. Phosphorus, we got 1. Chlorine, there's 3. Chlorine, there's 1. Look at there. Here we have another uneven situation going on. I take a moment. I'm going to take a little drink of water. And you can maybe figure it out and where we're going to start. If you were thinking to start with this chlorine, you're correct. That's a really good place to start because this is balanced, this is balanced. So where should we start? Let's start here. So we got the chlorines. If I put a 3 here, that will fix our chlorines. Our chlorines will then distribute here. If you look at our oxygen, oxygen in this case is going to have 3 plus 3 is going to give us 6. Kind of going a little backwards, but 3 times 3 on here is going to be 9. Oh, did you catch it? It's actually not 9. 9 is right here, but don't forget about that 3 extra there. So 9 plus 3 is going to be 12. That's a really common mistake, and I wanted to make sure that you had a chance to also catch it. And then 3 times 2 is going to be 6. So check, the only thing that's balanced now is that phosphorus. It looks overwhelming, I promise. Bear with me. Stay with me. Check this out. So we got 6 on this side, we got 2 on that side. What number can we put in front of here to make it be 6 on this side and 6 on that side? What times 2 is going to be equal to 6? If you thought 3, let's do it. Let's put a 3 in front of there. That's going to put, that's going to give us 6. 3 times 2 is 6. 3 times 4 is 12. 3 times 2 is 6. Voila! Check it out. We got 6 and 6 and 12 and 12 and 6 and 6 and 1 and 1 and 3 and 3, and that is awesome. So the challenge question 3 was also a little easier than challenge question 1. So if I was to ask you about the coefficients, it'd be 3, 1, 3, 1. And last challenge question. This challenge question is certainly a little bit of a pain as well, but once I kind of map it out, if the more you get practice with balancing equations, the more that you'll feel more comfortable with them. So if you like balancing equations even a little bit, try to just practice some more, and let me know if you are interested in getting more practice with it. So I'm just, again, gonna look at everything we have here. Please notice I have this little cluster, this polyatomic ion, the NO3. I see it on both sides, so I can go ahead and keep that NO3 together. So I'm gonna do an NO3. Even though oxygen's also over here, I'm gonna keep NO3 together. That's my biggest recommendation whenever you're doing these bigger equations, especially when there's some kind of acid base or double displacement. We got Mg, and then we got an O, and we've got H right up there. All right, so here we go. Hydrogen, on this side we've got 1 and we've got 2. 1 plus 2 is 3. On this side we have 2. Already gonna be a little bit of a tricky here. NO3, we've got 1 NO3. On this side we've got 2 NO3s. Here I've got 1 magnesium, here I've got 1 magnesium. We're not gonna include this O3 on the counting because we already accounted for it here. So here we need to look at this. 2 times, this 2 is applying to this entire OH. That's where we get this 2 hydrogens plus that hydrogen. So we've got 2 times 1 is going to be 2. And then on this side we only have 1. So this one's kind of a mess, except for that lovely magnesium just holding balance. Easiest thing I'm going to recommend that you do in this case is we've got that little cluster, we've got that NO3 all stuck together. Let's balance it. So let's try to do that. So we're going to do a 2 in front of that HNO3. So that's now going to give us 2 HNO3. That's going to now change our hydrogen to an even number. So we had 2 hydrogens there, and 2 times 1 is 2. So we have 2 plus 2 is 4. We have 4 hydrogens. And now we need to go on this side. Those NO3s are balanced, but that hydrogen's not balanced. So in this case, what number can we put in front of that H2O in order to make that be 4 hydrogens? What times 2 is 4 is going to be 2. So then that is going to give us 4 hydrogens, and how many oxygens? 2 times 1 is 2. So here we go. Look at it. 4, 4, 2, 2, 1, 1, 2, 2. So lovely, amazing, incredible humans. Your coefficients for your last questions are 2, 1, 1, and 2. Please reach out if you have questions. I will help you.